Welcome to Rges Algebra 1. This is lesson 1.9. I'm labeling it word problems, but a better way to look at it perhaps is real-life examples on how to use algebra. Now, the key to using algebra is being able to recognize the relationship between different parts or different phrases or different conditions. And so this whole lesson will be about reading examples and being able to interpret English examples into algebraic expressions and equations. So in example 1 on page 34, go ahead, you'll want to look at your book while we're doing this section in particular. So put it on pause until you're ready. On page 34, it says, example 1, a cook makes $16 per day more than a waiter makes. Okay, so if we're talking about a cook and a waiter, my first question is which one is being related to the other? As far as I'm comparing these two, the cook is being related to the waiter. So let the waiter, how much he makes in dollars, be X, and then the information makes sense to me. I can easily come up for an expression with the cook. It says the cook makes $16 per day more than the waiter. So I would take what the waiter made, which is X, and add 16 more. So he would make X plus $16. And that is the key to the problem. So then it asks, write an expression for the dollars per day a cook makes. I already did that, right there. If a waiter makes $35 per day, how much does the cook make? Well, look at what the cook makes. The cook makes X plus 16, and the X is what the waiter makes, so I would substitute in 35 plus 16, and this would be B. Okay. And 35 plus 16, go ahead and evaluate that, and that would be 51, right? $51 per day. For C, it says if waiters get a raise to $40 per day, how much will a cook make? Well, we're assuming that the cook will still be in the same relationship to the waiters, but remember the cook is X, which is the waiter, plus 16. Now I'm substituting now for X, not for 35 anymore, but 40. Going ahead and evaluating that, $56 per day would now be what the cook makes. And finally for D, if a cook makes $65 per day, how much does the waiter make? Now that's a little bit different thinking. I hope you caught that. Now I'm telling you how much the cook makes. So, well, what does the cook make? The cook makes X plus 16, right? That's my expression for how much a cook makes. I know that the total now is 65. So this one becomes an equation. The other two were expressions that I was evaluating. This is now an equation because I'm given how much the cook makes, not how much the waiter makes. But I can solve. How do I solve? You've done this already, right? I'm going to do the opposite of that. I'm going to subtract 16 from both sides. Let's see, that would be, what is that? $49 per day. Let's go on to another example. Example 2 says, if parents have a certain combination of genes, then about 1/4 of their children will have attached earlobes. Let X be the number of children born to a group of couples with these genes. So we have the number of children total and we have the number of children with attached earlobes. Attached earlobes. Okay, I don't want to write it. All right, now, they've already told me if this is XX, then the number with attached, go back up to your problem, is 1/4 of X. How would I represent 1/4 of X? Well, I could either represent it that way, 1/4 of X, or 1/4 times X, or I could represent it as X divided by 4. These two are equivalent expressions. So A says, write an expression from the number of children with attached earlobes. I've just done that, and I've given you two choices, either 1/4 X or X over 4. B says, if these couples have a total of 532 children, well, which one represents total number of children? Which expression up above? The X, right? So I'm saying X is 532. About how many we'll have attached. Okay, so I write my expression for the attached, and then I'm going to substitute and evaluate. 532 divided by 4 equals 133. So 133 of them will have attached lobes. Always read the question again, make sure it makes sense to you. And then C would say, about how many children would the couples need to have in order for there to be 240 with attached. So I'm worried about the number, I'm given, I should say, the number of children with attached lobes. Well, I know the expression for attached is X over 4, and he's telling me that the value of that is 240. So be very careful that you can distinguish between when you need to just evaluate, substitute and evaluate an expression, or when you need to set up an equation, because of course the steps that you must do for one or the other are different. So how would I do this? Right now I'm dividing by 4. I would want to multiply by 4, and multiplying by 4 I get 960. 960 children in all. Total, right? In order for what? 240 of them to be with attached lobes. Always speak back to yourself the answer with words so that you're making sure it makes sense to you. On the bottom of page 35 and the top of 36, we have an oral practice. I want you to pause the tape doing each of these by yourself and then come back to make sure you understand the answers. Number 1 says 1/4 of. 1/4 of means 1/4 times. 7 less than X, begin with the X and take 7 less. Subtract out 7. Number 3 or C, these are actually ABC, but I'm doing it with numbers. 5 more than X, begin with the X and add 5. 3 fewer than X, begin with the X and take away 3. 5, 6 years older than X, begin with the X and add 6 to get 6 years older. The next one, really F on your on your page, 10 years younger, begin with the X and take away 10 years. So be very careful that you're beginning with the X in these. That would be an easy mistake for students. 4 times X, 30% of X. Okay, this is a good one. 30% of X. Change percent to fraction. Recall 30% means 30 out of 100 or 3 out of 10. Okay. So I could say it, well, I could say it a lot of different ways. I would be inclined to say 3 times 10 X. I could also say 0.3 30, that'd be 30%, 30 out of 100, x. I could say 0.3x because 30 out of 100 is the same as 3 out of 10. You have a lot of choices there. Okay. Next one, 90%. Again, I could just simply say 9.90 times x. That's also equivalent to 0.9 times x. That's also equivalent to 9x over 10, or 9/10 x. Whichever way you're more comfortable thinking about that. 10. 2.3 times as much. Well, in this case, obviously the fastest and easiest would just be 2.3 times as much, would simply be times. Okay. Times the x. There's the times. Okay. I would encourage you, as you do these problems, you're only assigned the odd ones, but I would encourage you to read through all the even ones and make sure they make sense to you also, and ask me about any odd or even ones once you get to class.